types of problems, okay? So in the first two, they were pretty straightforward because what you were doing is you were looking for either an equilibrium concentration, so something after it gets to equilibrium, or you're looking for the K value. So all you had to do was the rate law expression and just simply plug it into that formula, right? Very straightforward. Then when we got to number 3, it was a little bit different because this time what we were looking for was actually a missing equilibrium concentration, but what was different is you were given initial concentrations. So you knew how it started, but you didn't necessarily know how all of them ended up. So what you needed to do is you needed to figure out the change, and that's where the ICE table came in. So using this ICE table idea comes in really handy. But in each of these cases, you're given some information about what happened at equilibrium. And the other thing was, when you look at this question, you see that you were given initial concentrations usually for the reactants and nothing for the products. So if you're given everything for the reactants and these were 0, what do you know about the direction that you're forcing that it's going to get to equilibrium?
It has to the products.
Yeah, it has to go to the products, right? So it has to because you don't have any products. The only way to go is to the products. Now, number 4 is a bit different. So if you read number 4, it says carbon monoxide reacts with water to produce carbon dioxide and H2. So there's your formula or your reaction. It also gives you a K value this time, which is similar to some up here, but the difference is here it says that you have the concentrations for all of the entities. So both reactants and both products this time. And what do they want to know? They want the equilibrium concentrations. So if you read carefully, and this is question number 4, and here you want to find all the equilibrium concentrations. They don't give you one. And the other problems, it gave you one so you could use that to solve for X. But now you're not given one at all. And not only that, you have everything you need up here. So the question is, if you have a little bit of reactants and products, which way is it going to get to the equilibrium? Because right now, that's your initial. You don't know if you're at equilibrium or not. It's probably not done, so you don't know what the equilibrium concentrations are. You don't even know which way it's shifting to get there. So this is where we use that Q value. So Q is going to help us this time because Q is going to help us determine whether it's shifting to the right or shifting to the left. And if you check your notes, you have that little comparison. If Q is the same as K, you're at equilibrium. But if Q is less than K, what happens? Do you remember? Okay. If Q is greater than K,
Shift to the reactor.
okay, so you need to remember that. You get a cheat sheet on part 2 of the exam. So if you need to write those out, like those are kind of considered formulas. So those are good little reminders. But make sure you understand what that's about. So we're going to do Q. So let's see my upside down writing. So the Q expression is the same as the K. We are going to set up our Q. We have our products concentration at wherever we're at, initial, or it could be equilibrium, we don't know yet, over the products, and H2O, and we need to figure out what that is. So we're going to put in all the values, and if you're really paying attention, it's 4 times 4 over 4 times 4, and guess what that equals?
Oh, sorry.
Caught you on tape. Okay, so it's 1. Now, it's 1, which is fine. It's not the same as K, so it's not at equilibrium. So, K is 4.2, Q is 1, so that means Q is less than K. So which way are we going to go? We are moving to the product, so that means it's going to shift to the product. See if I can write that. Shift to products. Not bad, eh? Because it's less. So that means that these are going to go down by X, because we're going to let X equal the change again. This is going to go down. This is going to increase, and this is also going to increase. So you have to establish that. Now, if Q was greater than K, it would have shifted the other way, and these would have gone up, and those would have gone down. Okay, so that's the important part. in this type of problem when you know all the concentrations at initial and you don't know where equilibrium is yet. So now that we have that, double check your balancing. This is 1 to 1 to 1, so they're all x. You don't have to worry about coefficients. So now I'm just going to simplify it. I'm going to leave out my sig figs for now, but please make sure you put them back in when you start dealing with your final answers. All right, so I have my algebraic expressions. So now that I'm set up, I have my k, so I can set up k and my rate or my equilibrium law expression. So this time it's CO2 and times H2 concentration over CO times H2O. And I know what it is now. I actually have a value. This is 4.200, and I can plug these in. So I have 4 minus x times 4 minus x over 4 plus x over 4 plus x. So guess what you have to do?
Rearrange.
Right, now, we have a quadratic now. We're gonna have x squared, so guess what we may have to use?
Quadratic.
Which is a pain in the butt. And if you don't know it, put it on your formula sheet, make sure you know what it is. However, sometimes you get lucky. And if you look at this really carefully, there is a way for us to avoid the quadratic formula. It's a perfect square, absolutely. So if you can recognize this as a perfect square, all you need to do to avoid the x squared is to take the square root. So this will be nicely the square root of 4.2, whatever that is, you guys can plug it in, and then it's going to be 4 minus x over 4 plus x. Okay, solve for x. You can pause it. For that, what you're looking for, you need to know the change. You're going to represent it by x. You have to determine which way it's going to know whether you're adding or subtracting x. Then it's simply a quadratic. If you're lucky, it's a perfect square. If you're not, you'll have to use a quadratic formula. Solve for your x. Don't stop there because the question didn't ask for x. It asked for the equilibrium, and then you can plug it in. And just make sure that you're putting your products over your reactants so you don't reverse your signs like we did the first time. Okay? That's that. Now, what I recommend is trying the textbook ones first. You have a good practice on those. And then once you're done that, there's a whole page here. Now, watch out. The first one here is a qualitative. It's playing around looking at how the coefficients in the balanced equation are changing and how that impacts it. Okay. Apart from that, I think they're all quantitative ones. Watch your sig figs.